Leave off where we were last time talking about buffers. And I'm a big fan of buffers, actually. And buffers are extremely useful in my research because they keep the pH of things constant. So if you're going to do any kind of biology research or biochemistry research, you need to know about buffers. And as I'll mention later, also your body needs to be buffered appropriately. You don't want large concentration changes in pH in your body, or things won't function properly. So buffering is very important. So let's go over buffers. So if we talk about an acid buffer, that's something that's buffering on the acidic side of the pH range. And in that, you want to have play on both sides. So if you add a strong acid, it can be neutralized so the pH stays the same. If you add a strong base, that'll be neutralized so the pH stays the same. So what happens? You have to have an acid and its conjugate base in the mixture to have a good buffer. So what the weak acid is going to do is it will transfer protons or hydrogen ions to hydroxide ions that are supplied by the strong base to neutralize that strong base that was added. So you need to have an acid in there that's capable of giving up a proton to neutralize the hydroxide ion that was added. You also need to have the conjugate base. The conjugate base is going to accept protons if an acid is added, thereby neutralizing the effect of that added acid. So again, you need a weak acid and its conjugate base. You need both to have a good buffer. So I've been talking about weak acids and weak conjugate bases. So why would a strong acid and the salt of its conjugate base not make a good buffer? What do strong acids do? They dissociate almost completely, and that's not going to do you any good. You want to be able to shift that equation both directions. So a strong acid goes to completion, it's going to drive it to the right, and for a good buffer, you want to be able to switch things around that if you add a strong acid, then you neutralize that, you add a strong base, you neutralize it, so you need the conjugate to be effective as a base. And a strong acid has an ineffective conjugate base. It's not good as a base at all, so that won't work. So buffers are made up of weak acids and their conjugate bases, or weak bases and their conjugate acids. They need to be in the weak range, or there's no buffering capacity.